Okay, this should be Chemistry 35BBlake. And number 12, I think. Sulfuric acid is formed when sulfur dioxide reacts with oxygen and water. It's a two-step process. Okay? Three-step if you burn it from sulfur. So in this case, you should have written the balanced chemical equation. You get sulfur dioxide, water, oxygen. You should know the oxygen's O2. You should know water's H2O. Come on now. You should know sulfur dioxide from the name is SO2. And you should know sulfuric acid H2SO4. All of these we learned. Well, they gave you the anyway. And this is balanced as is. So I have 4 hydrogen, 2 sulfur, 4, 6, 7, 8 oxygen, and 8 oxygen there. So it's balanced. And the questions are, if we have 12.5 moles of this, how many moles of this do we get? How many moles of this? Again, if you write your mnemonic out, we are going moles to moles. That's just this little step. I showed you 15 first, so you can see the whole thing, and now we're doing all the little parts. SO2 is going to play the role of A in both of these. This is going to be B for one of them. This is going to be B for the other one, and it sets up pretty much like problem 11. So we're going to put what we're looking for over here, which is probably going to be O2 on the first step and H2SO4 on the second one. We're going to start with 12.5 moles of SO2 here and here over 1. And then we're going moles to moles in the numerators, because this shows you numerators. And then grams SO2, or moles SO2 has to cancel out. So it's moles of A, moles of B. This goes here. The ratio is 2 to 2 for H2SO4. I guess they do that one first. And part B. These numbers only go in this step. Notice how these are red. That's in red. You don't see red there and there. They don't go anywhere else. Don't put them somewhere else. And then that's just, this is 1, so it's just 12.5. If we do the same thing for O2, this is A, that is B. So we start 12.5 moles SO2, moles B is moles O2. But this goes here. And the ratio is 1 on top to 2 on the bottom. Moles SO2 cancels. Half of 12.5 should be 6.25. Okay, so let's go on to 13. So this should be 12.5, that should be 6.25 moles O2. Number 13. Got to turn the page. Sodium chloride is decomposed into the elements sodium and chlorine by means of electrical energy. How much chlorine gas is obtained from the process diagrammed at right? Well, if you're on that page and you read that question and look at the diagram, you could write the equations. It's going to look like that. They're even telling you CaCl2. You're supposed to know that. You're supposed to know this. You're supposed to know this. Well, they do tell you you're starting with 2.5 moles of sodium chloride, and they want to know the grams there. So start with your mnemonic and map out what you're doing to make your job easier, setting this up. You're starting with moles of A, and A could be something on this side, by the way, and B could be something on this side. But you're starting with sodium chloride is playing the role of A and chlorine is playing the role of B. We're going to go moles to moles and then to grams as the last step. So we want equals X grams Cl2 over here, 2.5 moles NaCl over 1 over here. So then This tells you the numerator. So we're going to go moles of this, 2 moles of that. That's going to be moles Cl2. To grams of that, grams Cl2. This goes here. This goes here. From the periodic table, it tells you what to do. The moles of chlorine is 35.5 times 2 is 71. I'm sorry, the grams of chlorine is 71 per mole. And from the balanced chemical equation in red, that's 1, that's 2. So we're going to go back to 35.5 times 2.5 because we're dividing by 2 here. Notice that cancels, that cancels. And when you're done, you get 88.75 grams Cl2. You wouldn't know how to do this on your own for any business. Okay, I'm going to make so many pizzas. How many packages of pepperoni do I need per week? You know, or something like that. Number 14, challenge. Titanium is a transition metal used in many alloys because it's extremely strong and lightweight. Titanium tetrachloride is extracted from titanium dioxide using chlorine and carbon. Carbon that comes from coal, where they heated it up and cooked all the tars out. And instead of charcoal like you get with wood, you're going to get coke. Although if you go buy charcoal briquettes, Kingsford charcoal briquettes at the store, it's really made from coal. So on that one, they give you an equation. And you want to know the grams of everything. And they balance that equation for you. So that's the mass of Cl2, the mass of C, and the mass of the products. So first they ask you the mass of this, then they ask you the mass of this, then they ask you the mass of these two. So that's 4 calculations, but all of them go moles to moles of, this is A, moles of A, this is B, and then this is B, and then these two are each B in turn. And then grams of B. So question mark grams, question mark grams, question mark grams, question mark grams. I find that when students take the time to set this up the way I do, they do just fine. When they want to cut corners and not pay attention, they run into problems and they think they can make it up later. And they get in a jam. Okay, so first let's do moles A to moles B to mass B. Notice I've got moles titanium dioxide to moles chlorine to grams chlorine, because grams is mass. So this tells you the numerators. And then this goes here, and then this goes here, and they cancel. From the first step, the balanced chemical equation is one of these to 2 of those. And a mole from the periodic table of chlorine is 35.5 plus 35.5 gives you 71. You multiply the tops, write it down. Multiply the bottoms, write it down. Then divide, although these are all ones, so. And it comes out when you punch down on the calculator to 177.5 grams of chlorine. Then on the next one, you're doing this one. You're going moles A to moles B to grams of B. That's what the numerators are going to be. So moles of A is moles titanium dioxide. It's a very bright white compound. In the paper industry, we used to use it as a filler for paper to make the paper less see-through and more bright. And then moles of B is moles of carbon, and then grams of B is grams, or mass of B is grams of carbon. From the periodic table, carbon is 12 grams. A mole of carbon is 12 grams. A mole of carbon is always 12 grams. That number's 1. You don't put that number here in there twice. That's the spot for it. So A carbon and A titanium dioxide. Moles titanium dioxide cancels, it goes here. Moles carbon cancels, it goes here. Multiply the tops, multiply the bottoms, then divide. A quarter of 12 is 3, so this should be 15. 15 grams of carbon. The next two are the same way. This is A, B, or mole A, mole B, then grams B, mole A, mole B, then grams B. So take a moment, pause this, set this up, write these out. Moles A, moles B, grams B, moles A, moles B, grams B. This here, this here, this here. Cancel it out, see if you get it. And then check your work. And you should end up with this. 235 grams titanium tetrachloride and 55 grams of carbon dioxide, and the total of these two together should be about 290 grams to answer the question. Okay, and then we've got question 16. I think you're supposed to go all the way up to 21, right? Okay, we're going to pause this here because we did 15 already.